In this video, we'll be writing a program that prints prime numbers within a given range from smallest to largest. This video is a response to a comment that was on video titled C++15. The comment says, how about a program that accepts two integer values, smaller value then larger value, as inputs and outputs the number of prime numbers from smaller value until larger value. A great question. Let's go ahead and do that. Now let's start by declaring two integer values, start and end. Let's then ask the user to enter the starting value. And we see that into start. We then copy these two lines and recycle them. Put the value into end. Here we want to loop from start to end. So for integer I is equal to start, I is less than or equal to end, we want to check the last value as well, and then we increment by 1. Then send each number within the range to the isPrime function, which we haven't written yet, to determine if it is prime or not. If it is, display that to the user. Let's go ahead and define our function. So we can define a function at the bottom, but then we first need to write the function prototype to let the compiler know that we have a function called isPrime. It takes in a number and it returns a Boolean value, which is either true or false. I'm going to copy the function header, I'll put it here, and we'll write a body in here. Now, initially, let's assume that all numbers are prime. And let's return the result. Next, what we want to do is we want to loop. Now, first, we know that numbers, negative numbers, and 0 and 1 cannot be prime. So for this case, we prove that these are not. So initially, we assume all numbers are prime until we prove otherwise. So this is our first condition that says no, it's not prime. The second thing is we loop through our numbers, or that num from I is equal to 2. I is equal to less or equal to. Now that equal to is important. I plus plus. Now what we want to do is we want to check if num modulus I does not give us any remainder. So the remainder is 0. We know that the value is false. So for example, if num was 4, the loop will run start from 2 and ends at 4 divided by 2, which is 2, so it's going to run once in here. If 4 by 2 gives us 0, that's not a 4 cannot be a prime number. So then in this case we break. There's no point in keep on going if the loop was gonna loop again. Okay, that's it. Let's see how we can call this function. So here what we'll do is we'll check if is prime and we pass the value of I. If true, in this case, we will display the value or that number, which is I, and followed by a new line. Let's compile. I need to declare my integer, my I, which I forgot to do. Looks okay now. Let's run it. Now let's go from 1 to 400. And did I forget a new line there? I'm out of done. Oh, and L, okay, and L. Compile and run. 1 and 400. And I've already got a list from Google beforehand. So 2, 3, 5, 7, 11. So it looks okay. I haven't gotten anything that So the last one 397 and so on. So it's looking fine. I haven't got anything that's suspiciously not a prime number that's being displayed here. So 374749. Yep, looking good. So I hope this is what you wanted. In the meantime, I'll see you in the next video.